Make a thought about the magnetic field. Consider the iron filings sprinkled on this piece of paper. What do you think is underneath the piece of paper? Video that we observe. What do you think is underneath the piece of paper? What do you think is underneath the piece of paper? Yes, sir?
I think it's a steel.
You think it's a steel? Is it a steel?
No.
Another one. What do you think? What is underneath the piece of paper? Yes, sir?
Because it's a bar magnet.
It's a bar magnet. Is it a bar magnet? It's a bar magnet. So what do you think is a bar magnet? What makes you think it's a bar magnet? Anyone?
I think it's because there is a magnetic field.
Because there is a magnetic field.
Yes.
Is that correct?
No.
What do you think? Yes, sir.
It is because iron filings arrange themselves in the pattern of the magnetic field.
Iron filings arrange themselves in the pattern of the magnetic field. Okay, he said it's because there is a magnetic field, but we didn't know really there is a bar magnet underneath the field. But he knows that iron filings arrange themselves in the pattern of the magnetic field. Therefore, we conclude there is a magnetic field. You understand, sir?
Yes.
Because of the iron filings, they arrange themselves in the pattern of the magnetic field. Therefore, we conclude there is a magnetic field. Therefore, it's a bar magnet. You understand?
Yes.
So today, we will learn about electromagnetism. From grade 10, you learn magnetism. So today, we will learn about electricity and magnetism. You understand?
Yes.
So be ready. I will play you another video. You have to observe it. And then I will ask you questions. Understand?
Yes.
So here's the video.
Pause.
With the consideration of the previous video clip, which end of the magnet is a south pole? The left hand end is the south pole. Now consider these small compasses with blue tip and silver tip. Which polarity does the blue tip has? If the left hand is the south pole, then the silver tip is the north pole, since north and south are tracks. Therefore, the blue tip is the south pole. From the video that we have played, which side of that bar magnet is the south pole? Which side is the south pole? Anyone? Anyone? Which side is the south pole? The left hand side or the right hand side? If you know the answer, yes sir?
The left hand side.
The left hand side is a south pole.
Yes.
So what makes you think it's a south pole? Yes sir? Because it is at the top. Is it correct?
No.
Is it a scientific answer? My sister, what do you think? You forgot the concept from grade 10. Okay, let me reverse you the stuff from grade 10, magnetism. So, determining the direction of the magnetic field in a bar magnet, right? So now let us consider this bar magnet. We have the north side and the south side of it, right? So there is a magnetic field around the bar magnet, right? So what instrument are we using to determine the direction of the magnetic field? We're using a compass, right? And previously we have seen that iron filings determine the presence of the magnetic field, but iron filings cannot determine the direction of the magnetic field. So we want the direction of the magnetic field. We use what is called a compass. We use the compass to determine the direction of the magnetic field. Compass, it has a compass needle. A compass needle always points to the north pole. If I can put a compass in, a compass needle will point to the north side. A compass needle always point to the north pole. So James here gave me a correct answer, but he didn't have an explanation. So in science, we must know how to explain things. Understand, James?
Yes.
So he gave, I think he even guessed the answer because it was left or right. So he guessed left. So now you will understand why you guess left. Because of, we see the compass, and then the compass needle points north. So obvious, if it points north, therefore that side that the compass needle have point, it means it's a north pole. Because it always points north pole. So therefore, the opposite side is south. You understand?
Yeah.
So this is how a compass works. We will use it in other physical. So since I have given you the prior knowledge of magnetism, so now we will focus on electromagnetism. Is the topic that we will focus at in this grade 11. So first, we will look at current carrying conductor. Current carrying conductor. If we have a charge and the charge is moving, that charge, it produces the magnetic field around it. So in electricity or an electric current is the rate of flow of charge. It means when there is an electric current, there is a movement of charges, right? And we know that if the charge moves, the charge produces a magnetic field around it. So if we have a current that is moving, or if we have a current, obviously the current is moving, the current is the rate of flow of charge, right? Therefore, around that conductor, there will be a magnetic field around it, right? Because there is a charge and the charge is moving, and then a moving charge produces a magnetic field around it. No? So this is what happened. We have learned about electric circuit. So this is an electric circuit. Conventional current. A conventional current moves from positive side of it through the circuit to the negative terminal of the battery. So let us consider this part A, B. This part A, B. So current is moving this direction and then this direction. So let us take this part A. So this is down. So how would we determine the direction of the magnetic field around this current carrying conductor? How would we determine the direction of the magnetic field around the current carrying conductor? What instrument can we use to determine the direction of the magnetic field? A compass, right? So we can put a compass near the current carrying conductor. So if we put the compass, therefore, we can see the direction of the magnetic field around. You understand? So this is what happens. It's a pity we don't have apparatus. I will show you experimentally so. So it's a pity we don't have apparatus. So, but if we can put also the ion filings can arrange themselves in the pattern of the magnetic field, right? Yes. So another thing, we have a rule that we can use to determine the direction of the magnetic field, right? Yes. So this is what is called a right-hand rule. A right-hand rule. So I will just explain to you right hand rule. What happens? A thumb, it will point in the direction of a current. A coil fingers, it will point in the direction of the magnetic field. Right?
Yes.
So a thumb in the direction of a current. Right? Coil fingers in the direction of the magnetic field. You understand?
Yes.
So what do you think the direction of the magnetic field is? Is it clockwise or anti-clockwise? Anti-clockwise? Is it correct? What do you think?
Clockwise.
Is it clockwise?
Yes.
It goes like this, right?
Yes.
Which is clockwise, right?
Yes.
Do you understand why it's clockwise? Because it goes like this. It moves like the classical watch. So you understand. So here there are the tools we can use to determine the direction of the magnetic field in the current. A dot, we will represent it as upwards, or out of a page. Dot will represent as upwards, the opposite of this, upwards or out of a page. You understand?
Yes.
So a cross will represent a cross as downwards or into the page. That's correct. Cross is downwards just like this. And we have already indicated the direction of the magnetic field. We said it's clockwise or into the page. You see, this is clockwise, right? So this is what will happen. This is what will happen. So let us consider this example. The direction of the current downwards on this conductor AB is going downwards, right?
Yes.
So according to that instruction, we want to draw the magnetic field around the current carrying conductor. Is it into the page or out of the page? The current is moving downwards. So I want the direction of the current. It's represented by the thumb, right? The right hand rule. So is it out of the page or into the page? I want to draw it that way. This one is downward. Out. Here are the answers. Into the page, right? It's into the page because it's going downward. We say downward is into the page. Upward is out of the page. So it's into the page. So what we will draw, this is what we will draw. We'll draw a cross, right? It's into the page, right?
Yes.
So then we'll draw another circle, maybe 2 or 3. So now we want to show the direction of the magnetic field in the current carrying conductor. So this is what happened. These lines represent the magnetic field around the current carrying conductor. So we say right hand rule. This is your right? A thumb, the direction of the current. And the direction of the current is into the page. And then coil fingers, the direction of the magnetic field. So the magnetic field is moving this way. So, is it clockwise or anti-clockwise? Clockwise, right?
Yes.
So the direction of the current will go this, then this way. So then if it is clockwise, it will go like this, go like this, go like this, go like this. Then done. You are done with the representation of the magnetic field around the current carrying conductor AB. You understand?
Yes.
So now, here's the class work. Sort of a class work, but it's short. 2 minutes. We have the current carrying conductor CD is moving upwards. So in your class notebook, draw for me the magnetic field around the current carrying conductor, and shows the direction of the magnetic field. Also show the direction of the current using the right hand rule. Yes, then exercise DC. You have to draw fast. 2 minutes. You can refer on those dots. Upwards, right hand rule. Upwards, downwards. You're done, sir. You're done. Let me see. So it's upwards, right?
Yes.
It's out of the page. Oh, this is right hand rule out of the page, and then it is anti-clockwise.
Yes.
This is correct. Where is my right hand? This is correct. This is correct. I'm impressed. Another one. Another one. Brother. Just do it. You see, it's out of the page. You have to show your errors. I understand these are going this way, but you have to be clear. You have to be clear right here. Understand? Out of the page. This is correct. Are we all done? Let me see yours. So it's out of the page, right hand rule, right? Out of the page, anti-clockwise. This is correct. This is correct, right? So is it out of the page? I'm impressed. I'm impressed. Sir? Even if you are writing with a red pen, I don't like it. You have to write with a blue pen. Right hand rule, out of the page. This is correct. Give me your pen, a mark. You're supposed to write with a red pen, brother. And I have to take this red pen. It's mine now. You say into the page. Current is going up, right? But the direction of the magnetic field, if it was out of the page, is correct. So let us try. It's upwards. What did we say about upwards? Out of the page, and we represent it by
Dot.
a dot. So you write a dot. So you put your right hand up, out of the page, right? So what will be the direction of the magnetic field? Write me the direction of the magnetic field. Write it there. Out of the page. So I wanted you to, this is the direction of the current, right? This is out of the page, is the direction of the, it goes like this, right? Out of the page, and then anti-clockwise. This is the direction of the magnetic field, you understand?
Yeah.
So I have seen that you understand to determine the direction of the magnetic field around the current carrying conductor. We were specifically looking at the straight wire, right? Yes. So now we want to look at the coil. How do we determine the magnetic field around the coil? This is what would happen. Let us think like that. Wire AB. Then now we bend it like this. And we put it on a cardboard like this. Oh, I'm not good on drawing three-dimension shapes, but I will try by all means. So it goes here, it goes here. This is point A, this is point B, right? Let us assume now the current moves from this part outwards, and then it comes back, it enters this part, then outwards C. Still, we are still using the same rule, right hand rule, right? Let me check. Explain to me right hand rule. What does the thumb represent? Sister? What does the thumb represent? Anyone? What does the thumb represent? We say the thumb and the cold fingers, one of them, they represent the direction of the current and the magnetic field. So what does the thumb represent in the right hand rule? It represents the direction of a current, right? So the cold fingers represent the direction of what? It represents the direction of? It represents the direction of magnetic field. Understand? So you have to know the right hand rule by head or by heart. Just like you know your numbers, phone numbers, right? So still we are using what? The right hand rule. So it will go, what do we say? And then the direction of current is upwards. So I want to represent A this at this, right? I want to represent A at this point. So the current is upwards. So according to the right hand rule, will I represent it with a dot or cross? Yes, sir?
A dot.
Yes, sir. With a dot, right?
Yes.
Because dot is upwards. Right?
Yes.
So we'll represent it with a dot. So how will be the direction of the magnetic field? Right hand rule. Clockwise or anti-clockwise?
Anti-clockwise.
Anti-clockwise, no?
Yes.
The round right hand rule out of the page and then anti-clockwise. Just like you see, it's the same thing, right?
Yes.
So then let us consider point B in here. This point B. The current is going downwards. So, how would you represent the direction of the current in it? Cross or dot?
Cross.
With a cross, because it's going downwards. Right?
Yes.
So, right hand rule is into the page or out of the page? Mrs.?
Into the page.
Into the page, right?
Yes.
And the direction of the current? Yes?
Clockwise.
Clockwise. Clockwise, just like it will go like. This is simple, right?
Yes.
Simple to determine. So if I can continue, I want to show you something. If I can continue drawing those lines, magnetic field lines, this is what will happen from that part. And then it will go like that. So, and then we know this part is clockwise, anti-clockwise, it will go like this. This part is clockwise, right? It will go like this in this part of it. This part of it will go like this, right? This part of it will go like this. So I want to determine the polarity of these two the representation of the magnetic field, right?
Yes.
I want to determine the polarity of it. So let us go back a little bit from magnetism in grade 10. Oh, let's all focus on this. Let us look on at the bottom. From grade 10 we learn this is north part of it, this is south part of it. From grade 10 we have learned that a magnetic field moves from north pole to south pole, right? Move from north pole to south pole outside the magnet, right? So we draw it like this and we draw it like this. It goes into, it moves from north to south. So I want to determine the polarity. When I'm talking about polarity, I'm talking about north and south pole. This is the polarity, right?
Yes.
So when we see the magnetic field lines going out is the north, right? When we see the magnetic field lines going in is the south. Let us come in this way. So the magnetic field here is going out. Is it? Let us do it. Going out, it's going in. Here the magnetic field is doing what? It's going in. Is it correct?
Yes.
The magnetic field is going in. So, which part of it is the north pole and south pole? Up or down? Which one? Yes, sir.
Another part is South Pole.
South pole.
Another part is South Pole.
This is south and this?
No.
This is north. You see what happened?
Yes.
This is what happened. This is south pole, this is north pole. So we refer on the bar magnet. Simple?
Yes.
Cut. So in this figure, hey, you guys stop making noise. In this figure, you have to do it on a classroom. You draw the magnetic field around point A, you draw the magnetic field around point B. So I represent the direction of the current with this arrow. We are going like this. So do it now. Without a waste of time. Do it now without a waste of time. Draw the magnetic field. You don't have to draw the whole structure. You just represent for me the magnetic field on point A, the magnetic field on point B. Just like this. So and then after drawing, you have to represent the polarity of it. Show me the north pole and the south pole. Which side is north, which side is north, is south. I don't say. So let's start with this one. Which one is A?
Sorry?
Which one is A?
This one is A.
This one is A.
This one is B.
So then from A is downwards.
Yes, it's from downwards.
It's supposed to be into the page or out of the page. Downwards.
Downwards must be into the page.
Downwards is into the page.
Yes.
Look at those right hand rules. Downwards. Downwards is into the page, right?
Yes.
So then your dot is into the page or out of the page.
It's into the page.
Dot represent what?
With the
Look at the right hand rules.
right hand. Right hand.
Use your right, not left. Dot is out of the page, right?
Yes.
According to the right hand rule. So point A on that diagram is going downwards.
Yes.
So it's supposed to be into the page or out of the page?
It's supposed to be into the page.
Downwards. Look
Yes.
at the right hand rules. Right hand rules. Dot is upwards or out of the page, right?
Oh, yeah.
Cross downwards or into the page. So at this point A, it's supposed to be cross or dot.
It's supposed to be dot.
To be dot. Look at that point A on that diagram. It's going. The current is going downwards. Current is going downwards. Yeah, that's point A. Current is going downwards. And downwards represent what? Cross.
Yeah.
Is it?
Yes.
So you have to write cross. Fix it. And then use right hand rule. Let me see. Okay. A, this is A. This is B. So then A is going downwards, right? It's a cross, which is into the page, which is correct. B is outwards, out of the page, right hand rule is correct. And then supposed to be like this, the bottom is okay. So it's supposed to be like this. This arrow here is supposed to go like this. You see? Supposed to go like this. So this arrow, you see, it follows this one. Here it's supposed to go like this. It's supposed to go like this. So here is going out, here is going in. So which one is north, which one is south?
Okay, this one is north and south.
Speak loud.
North, south.
This is north, this is south. You see?
Yes.
That's it. Let us focus on the correction of it. So then point A, we said the current is going downwards, right? So when it is downwards, according to the right hand rule, we'll represent it by cross and cross into the page, right? So tell me, what will be the direction of the magnetic field on point A? Clockwise or anti-clockwise? Clockwise, right? Go like this. It will be clockwise. So we look at point B. Point B. So the current is going upwards, right? What will be the direction of the magnetic field? It's going upwards, current. What will be the direction of the magnetic field? First thing first, current will be represented by dot or cross. Dot, right?
Yes.
Dot means out of the page. And so out of the page, it will be clockwise or anti-clockwise? Anti-clockwise. Just like this. It will be anti-clockwise. And we did represent the direction of current and magnetic field. We did represent the direction of current and magnetic field at point B. So now they want the polarity of this structure, right? So in order to determine the polarity, just have to add more of the magnetic field lines. Just like this. So if we can check, at this part of we align it with these arrows, right? Because they are part of point B. So it goes like that. So even this part we align it with these arrows. Right? You see? So it's going into, so this part is going out. And what did we say about the polarity of the bar magnet? In the bar magnet, we have shown that magnetic field move from north to south, right?
Yes.
Outside the bar magnet. So which side is north? Which side is south? Up or down? Yes. Down is north, and up is south, right?
Yes.
So I expect this way into your corrections book, right?
Yes.
So when we meet again, we will learn about the solenoid. We have learned about the straight line wire, the current carrying conductor, which is a straight line, and then we also learn about the current carrying conductor of a loop, right?
Yes.
On a coil. So now, in the next class, we will learn about a solenoid. So we will look at the solenoid, something like this. So it will be your homework to go and research the right-hand rule of a solenoid. Right?
Yes.
Right-hand rule of a straight line wire and a coil wire is not the same as a solenoid. Right?
Yes.
So let's take the current, it goes at the back, and then it comes like this, and then out here. So we will explain what is happening. But the main idea here, we want to explain to you an electromagnet. you know we have a bar magnet, and then I want to explain to you an electromagnet. An electromagnet is usually used at ESCOM. They don't have, mostly they don't have giants or big bar magnets. So they use electromagnet to generate electricity. So for example, let me show you some examples. This is the solenoid that I'm talking about. You can relate, right?
Yes.
So you can join your conductors in here. So this is a bar magnet. I will explain in more details about Lenz's law and Faraday's law. If you put a bar magnet, there is a generation of electricity. So this is what is happening at power station. The mechanism that they are using of a solenoid. So in the next class, we will deal about the solenoid. So your homework is to go and research about the solenoid. Go and research about the right-hand rule of a solenoid. I don't usually give learners homeworks to do and write, go and write a homework because someone can write it for you. So I'm not sure whether that homework you did yourself or someone did it for you. So I will be convinced that you have really go and research because when we come to class, I will ask you one by one, what did you learn about the solenoid? Right? You are a science student, you have to learn on your own, you have to discover things. Right?
Yes.
Bingo. So now we can move on.